Hello, welcome to Schneider Electric's EV learning session. My name is Adrian Duque. I'm the offer manager for electric vehicle charging solutions here in New Zealand. Today I'm going to be discussing more about our offers, of course, and at the same time all the trends, the drivers with regards to the uptake of EV, and of course the regulation around that. All of us would agree that cleaner mobility is quite a trend now, and it's a must. So one of the drivers there is that cities have actually banned diesel engines, or what we call internal combustion engines, running in their cities on certain years. So they have committed to this, and it could be some of the cities like Paris, Madrid, and also there are car manufacturers that have actually committed in reducing the cars that they manufacture from internal combustion engines into electric vehicles. These are some of the examples, and the last one that I saw was actually Jaguar. With the launch of their new model I-Pace, they've actually committed that by 2030, 100% of the cars that they manufacture would be electric. Looking at the global electric vehicle market, the end of 2017, we approximately have around 3 million electric vehicles in the world. As you can see from the trend, looking at the chart on the left, from 2013 to 2017, you can easily see the uptake increasing year by year. And looking at the right one, this is basically showing the electric car market within each country. So leading the way would be Norway. They have about 39% of their total vehicles within the country to be electric. Next slide, we'll be looking on a local view of electric vehicle uptakes. So at the moment, we've got around 10,000 electric vehicles. So if you look at the trend, it actually follows what the global trend is doing. It's continuously going up. And looking at the right side, you can see year by year how it is progressing. All right. So majority of the EVs here in New Zealand is concentrated in Auckland. Like 46% of that would be in this region. Nissan Leaf, still the popular choice, either a second-hand Leaf or a brand new one. That's the majority of the electric vehicles in New Zealand. And of course, lastly, which is quite a surprise, individuals actually own more of the EVs compared to companies. This just shows how individuals are doing their thing with regards to contributing for a cleaner and greener New Zealand. And in terms of incentives, one of the primary reasons that Europe is actually the leading adopters of electric vehicles are the incentives that they receive. So each country, they vary in terms of tax incentives, or even when you purchase a new vehicle, you get incentives in terms of financial support. So in this case, from the highest that I've seen, you can get as much as 10,000 euros if you're buying a new car. In New Zealand, we've got some support, not as heavy as what the other countries are doing, but we do get some exemptions in terms of road user charges, and also the government is doing their part by providing funding for projects with regards to electric vehicles. So such projects can be changing a part of their fleet from normal vehicles to electric vehicles, or even investing into charging infrastructure, even in terms of research. That's part of that. Now going into the actual electric vehicles, we've got two types that we consider. First would be a battery electric vehicle. So this is purely batteries, purely electric. And the other one is what we call a plug-in hybrid. So this is one part electric and one part using a combustion engine, or using petrol, sorry. In terms of probably familiar cars or familiar brands, the battery electric vehicle can be considered as your Nissan Leaf. Your plug-in hybrid could be your Mitsubishi Outlander. So the main difference here would be battery electric, pure electric, range is quite far, ranges from 100 plus to 400 depending on the model. For the plug-in hybrid, since most of the time they're using petrol, the battery part would have a range of only around 50 to 60 kilometers. So looking at the actual EV, there are actually four major components that we have here. First would be your electric motor. So this varies depending on how big the vehicle is, how much power it requires. The second one would be the battery set. So this actually determines the range that you can travel. So it goes from 100 Ks to 400 Ks depending on the manufacturer. So the bigger the battery, the longer you can drive. The third part is the onboard charger. So this determines the charging capacity of the vehicles. Each manufacturer has their own rating, ranges from 3.7, 7.4, even to 22 kilowatts for three-phase. So this onboard charger is basically what takes care of converting AC coming into the vehicle, converting it to DC to charge your batteries. And the last part would be your charging inlet. So the charging inlet in the market, majority would either be type 1 or type 2. There is an exception to that, which is Tesla. They made their own charging inlet, but that's specific for them. But majority of the market, excluding Teslas, it's always either a type 1 or a type 2. So in terms of charging, we've actually got 4 modes. We've got mode 1, 2, and 3, which looks after AC charging. Mode 4 talks about DC charging. So talking about mode 1, this is something, as you can see from the diagram, it's something that you directly plug into your electrical socket and charge your vehicle. You may notice that in between that, there is nothing. So there's no management of the power coming into the vehicle. So it's just purely AC going into your vehicle. In some countries, mode 1 has been banned, mainly because of safety reasons. As I mentioned earlier, there's nothing in between in terms of management of the power coming into your vehicle. Mode 2, when you buy an EV, usually it comes with a charger. And those chargers are mode 2 chargers. It's something that you plug into your normal socket to charge your vehicle. But the difference with mode 1 is, as you can see from the diagram, there's something in between that, which actually manages the charging of your car. So this is safe, this is allowable, this is acceptable. The only setback is that it would take your car about 8 to 12 hours to charge. Mainly because it can only do a maximum of 2.3 kilowatts. Right? Mode 3 is the most common charging out there in terms of AC. So mode 3, the main difference between the first two is that this is permanently wired to either the house or the site, or to the electrical infrastructure of the building. So in this case, what you will have would be a charging station either having a tethered cable or a socketed version, which means the charging station would have a socket and you bring your own cable, plug into it, and plug into your car. So this mode 3 is a probably more efficient, more safer way to do your charging. It's more advanced compared to mode 2. A lot more things you can do there in terms of management, recording information, doing load shedding, and all the smarts that you can do. Mode 4, this is what we're now talking about DC charging. So this bypasses the onboard charger of the vehicle. So it's DC coming in and going straight to your battery, being managed by what people call a battery management system. So this is directly putting in DC and DC to your batteries to charge it. That's why it's faster, because it bypasses that conversion. All right? And another thing is that it's high powered. Usually starts at 22 going to 350 kilowatts DC. Plugs vary depending on the car. There are 2 main plugs out there, type 1 and type 2. So what I'm grabbing here would be type 1. It's mainly used by the Japanese brand. It's actually originated from Japan. The Nissan Leaf used this mainly because it can only do up to 7.4 kilowatts or single phase. The other one is type 2. So this is prevalent in the European market. A lot of cars that are new, or the newer models, are adapting type 2, mainly because they can do single and 3-phase, which means they can handle higher power. As technology progresses, you've got better batteries, longer range, which would need higher power. That's why they're shifting to type 2. All right. So as you can see here, you've got the different brands there who's used the different types of plugs, type 1 to type 2, and they do vary depending on the manufacturer. So the next slide shows you what car manufacturers are offering. So you've got a division here on the top part. You've got your plug-in hybrids, and the bottom part would be your pure electric vehicles. And the numbers on top of the chart, you would see 3.7, 7.4, 11, and 22 kilowatts. This is basically the onboard charger of the vehicles. And at the bottom, you can see if it's single phase or three-phase. Most of the vehicles currently are still on the 3.7 range. So those are the onboard chargers that they have. But looking at in the future, a lot of car manufacturers are already moving to the next column, which is the 7.4 range. And some cars have already, especially the long range ones, like the Teslas, they've already gone to 11 and 22 kilowatts. So this basically shows that even though majority of the cars there are still on the 3.7 kilowatts, it's actually moving now to have a more power, more range, larger batteries, which requires a bigger onboard charger. The next slide shows you some of the parameters that you should know if you're looking to buy an EV. Every manufacturer has their different sets of specifications. These are some of the more important ones. We're looking at the motor. Another important thing would be the battery set, which actually determines your range. You've got your onboard charger, of course. It's a factor with regards to how fast your charger can charge the batteries. You've got your inlets too, either type 1 or type 2. As I mentioned earlier, type 2 is becoming more dominant in the market, especially for the newer models. And of course, you have to look at if there's a need for DC charging too. So these are some of the specifications that you can see. And what we've got here, the four models here would be something that's quite common in New Zealand. So something that you can look at before really deciding on what brand or what model you're going to purchase. One of the main questions being asked is that how long does it take to charge an EV? There's no direct answer, or there's no one answer. It actually depends on three things: the charging station, the onboard charger, and lastly, the charging cable that you use. So what I've got here would be a chart showing the different specifications of some common vehicles. I'll take on two examples. Take note of the charging, the onboard charger, and also the charging station that you use. Okay? We're going to look at Renault Zoe and the Nissan Leaf. Take note, the onboard charger for a Renault Zoe is 22 kilowatts. The onboard charger for a Nissan Leaf is 6.6. Assuming that we use a 22 kilowatt charger, you can see there that it'll charge the Zoe in 2 hours. But if you look at that, go across the board, look at the Nissan Leaf, it will charge it at 6 hours. Main reason for that is that the Zoe can take 22 kilowatts coming from the charging station, but the Nissan Leaf can only take 6.6 kilowatts, even though the charging station is actually 22 kilowatts. That's why it takes longer, and that's why it takes about 6 hours to fill it up. And of course, not to forget the charging cable. If you're using a three-phase charging cable on a single-phase charging station, you will charge your car at a single-phase rate, which is usually around the 3.7 or 7.4 kilowatts. So those are the three main things that you have to look at. There's no straight answer, how fast you'll charge your car. It depends on three things. And the next question that usually gets asked next is that how much it will cost us to charge an electric vehicle. Again, it will be dependent on the car. But what I've got here would be looking at the Renault Zoe, which has a range of 400 kilometers. Assuming that I would charge it using a 7 kilowatt charger, it will take 6 hours to charge that. And it will give me 42 kilowatt hours of energy to be used. So if I apply the rate that I pay at home at 23 cents per kilowatt hours, we're looking at almost $10 to fill up a Renault Zoe that can go a distance of 400 kilometers. If we translate that to the normal vehicle, if a normal vehicle would have to go 400 kilometers, this is my computation, we're looking at a car that can do 10 liters per 100 Ks, and the usual price of around maybe about 230 cents per liters. multiply that by 4 to get 400 kilometers out of it, you'll end up with around $92. So this is not an exact computation, this is just based on some assumptions. But as you can see, what I'd like to show here is that the running cost for an electric vehicle compared to a normal vehicle is actually quite very far in terms of cost. It's much less, but of course it depends on the vehicle. Now we're going to talk about what Schneider Electric can offer in terms of EV charging solutions. First off would be our EV-Link wall box. For our residential and domestic offer, we've got the EV-Link wall box. Going into its specifications, it's actually quite easy to install. It weighs less than 10 kgs. The registered electrician can easily install this in probably half an hour. It's easy to maintain. As you can see, it's very simple, sleek. It's more of just cleaning it up. It's safe and robust. It's got an IP54 rating, an IK10 impact protection rating. Also, it's suitable for indoor and outdoor use. It's also for UV resistant. In terms of the rating, it actually has 4 ratings, 3.7 and 7.4 for single phase, 11 and 22 for 3-phase applications. It does have an energy management capability wherein it has an input which you can trigger to actually bring down the current that's flowing through the charger, of course, and then going through your car. You can actually trigger this by a timer or some sort of a load management device. So it's quite easy to use. You just plug and charge. You've got a button here to start or stop charging if you need to. The second tier of our offers is the EV-Link Smart Wall Box. You may have noticed a difference would be the word smart compared to the wall box, mainly because of its communication functions. The Smart Wall Box can be communicated to via either a 3G, 4G modem or via Ethernet, wired or through Wi-Fi, or last one would be through OCPP. So OCPP is the communications protocol that back-end providers use in order to communicate with electric vehicle chargers. Right? So just like the wall box, it's easy to maintain, it's safe and robust, IP rating of IP55, also has IK10 impact protection rating. So in terms of rating, it only comes in 2. 7.4 for single phase and 22 kilowatts for 3-phase. Another advantage of this is that it has a better energy management function compared to the ordinary wall box. The energy management function of the Smart Wall Box is actually more advanced compared to the standard wall box, mainly because the maximum charging current of the Smart Wall Box can be adjusted amp per amp, from 8 amps to 32 amps. So you've got a lot more control or flexibility over that. And also has a key lock compared similar to a standard wall box, but a difference would be an option for an RFID. So this is where if you would want more stringent user access management. Lastly, the EV-Link parking. This is our most popular or best-selling range in New Zealand. So this is our commercial offer. As you can see, it has a couple of form factors. One is a wall-mounted or floor standing. The EV-Link parking specifications is a bit similar to the Smart Wall Box, mainly because of the communication options, specifically OCPP. Since this is what you use for public charging, OCPP is quite important because usually they are actually integrated to a back-end system. It comes in various power, 7.4 kilowatts for single phase, 22 kilowatts for 3-phase. The main difference between the Smart Wall Box is, of course, the form factor. This is more robust. The housing is actually made of metal. And another thing is in terms of flexibility. What you have here would be a double socket EV-Link parking, left and right, but it also comes with a single socket version if you need that. So charging is quite easy. We always have a Type 2 socket on each side, and it's just a matter of lifting the plug or lifting the flap, plugging in the charger, plugging the other end to your car, and away you go. One of the things that our customers love about the EV-Link parking is that you can reskin the cover. We've got customers who actually took the cover off, put in their own colors for their own branding, at the same time put stickers, put their logos in there. So this actually shows their environmental commitment. One of the cool features that our EV charging stations have is that all the sockets on these stations have shutters. So shutters would be some sort of additional protection to cover the terminals, ensuring that no dirt or small particles get into them if they're not being used. Aside from the EV charging stations, Schneider also has accessories, and one of the main ones would be the charging cables. So what we have here would be, as you can see, thick cables, high strength, very durable. Comes in single phase or three phase, and it's always either a type 1 on the other, type 1 or type 2 on the car end, and it's always a type 2 on the charging station end. So it comes in 3 different lengths, 5 meters, 7 meters, or 10-meter cables, depending on your application. Another accessory would be the pedestal. So this is suited for the wall box or the smart wall box. So it's basically a pedestal where you can hang your EV chargers on either side, either 1 unit or 2 units back to back. The other accessories would be the cable holder. Some of our customers prefer that the cables are left in the charging station, so this cable holder actually keeps it neat and tidy. Another accessory is the DIN rail mounting kit. This is specific for the floor standing EV-Link parking. So the advantage of this is that instead of you spending a lot of time putting in your protection devices in the field, you can actually do this in your workshop. Put all the protection devices there. Once it's done, you can go back to the field, put it easily, spending less time there, and can easily be installed. What we've got here would be a list of some of the companies that we've sold to, from utility companies to private companies to retail companies and even hotels. And also, part of what I was talking about earlier is that the ability for customers to reskin the chargers that they've bought. So these are some of the examples from Waste Management, Orion, Toyota, even Vector. They put in all their colors there in order to show their commitment to the environment. One of the things that are important to know is that just like any electrical equipment, electric vehicle chargers do need electrical protection. So the most basic that you can put in would be an MCB and an RCD. For us, as Schneider, we do recommend putting in also an undervoltage release. So that's basically for, in the case that the contactor inside the EV charging station fails, it will shut down the unit. So based on WorkSafe New Zealand, these are the 2 things that you have to put in. Another thing to note is that WorkSafe New Zealand mandates that every charging station that is non-domestic has to be tested before putting into service and 12 months after that. So it's an annual check, like your warrant of fitness for your EV charging station. And lastly, this is to give you an overview of what an e-mobility ecosystem looks like. You've got your electric vehicle, you got your charging stations, which you actually install either at your home or public places or even private parking, and then it's being fed by the utility companies. From these 4, we've actually got customer care to help us and installers like electricians or contractors to do the install of all the charging stations. And one thing unique is that, if you can see the cloud illustration there, that's your back-end system provider, which actually has the capability to manage your EV charging stations in order to do billing or manage, turn it off, turn it on, get statistics out of the unit. So that's the end of my presentation. Thank you for your attention. I hope this has been very informative to you guys. And if you've got further questions, please don't hesitate to give us a call. We've got our 0800 number, and at the same time, you can visit our website if you want to download more information. Thank you.